Bismillah. Hi. Today I'll talk about the metallic bond. Um, Metallic bond is one of the three types of the physical bond. We know there's chemical bonds and there is physical bond. Chemical bond, there is many ionic, there is covalent. Even in covalent, there is many types, but ionic covalent, coordinate covalent bond. طيب الفيزيكال there is three types. We have hydrogen bond. We have also van der Waals. And this one metallic we'll talk about today. طيب metallic from the name of it. Metallic from the name, it's occur among cation of metal. طيب we know there is metal and non-metal. طيب I'll talk about metal today because we'll talk about metallic bond. طيب الميتال we said before it's like we'll say magnesium 12. A configuration of 8 to 8 2. So it's easy to release the electron. Last low valence shell electron, it's easy to get it out. Okay. To reach the stable condition as neon 10. Okay, since it easily for element like metals to release the electron, so it will come to be a cation. Okay, type. This cation in a metal arranged in shape like lattice, like this, okay. And where is the electron gone? Electron still here. Electron is still here, but unbound. It's free, delocalized, free movement. It's forming like sea of electron. Or we can say cloud. Cloud around or floating over the cations. And there is electrostatic bond or electrostatic attraction between this cation and this negative charge electron. Then, so this lattice with the floating electrons which forming cloud, creating attraction force between negative and positive charge called metallic bond. Right. That's affect or create special character for the metal. Why? Okay, it's like we'll say here like tubes. Okay, have positive. Same lattice what we said before. Okay. And here is the electron floating, making sea of electron. It's not attached to the nucleus. It's not belong to any atom. It's free, free, delocalized. خلاص؟ طيب suppose you just make connection of source of electric. What will happen? This is the secret why it's metal conduct electric quickly or very good conductor. Type source. What will happen? You know, like warm movement. يعني it's like example, huh? Warm movement. It will like this until get out. Type source of electric. Of course, it will stimulate or make the electron excited, and it will move. It's free, delocalized, and it's come here, come out. So it's called good conductor. Good conductor of electric. Okay. طيب, is all metal a good conductor? Not all. It's like variation, but the best conductor at all on our planet is silver. It's 47. Yeah, maybe you will say no, it's copper. Yes, but it's not like silver. So we know copper 29. I'll say you silver is 47. Type gold is I think 79. Yeah, 79. So copper, silver, gold, all in group what? 1b, meaning in outermost there is one electron. Okay. Type why silver is good conductor or the best even than copper, this one, aluminum, whatever. Why? That's it's referred to its lattice structure. Lattice structure of silver. And also it has one electron in its outermost. This is free to move. Just ready. Just with any signal he will fly. Alright, look, AG silver 47. We know it's like I'll say 1s2, 2s2, 2b6, 3s2, ss, so 3b6, 4s2, type, then s, da. So here 10, 10, 3d10, 4b6, and 5s with 4d. Well, you will think I'll vote for 5s2. No. Here, if I put 2 here, meaning I'll put 9 here, and there is no d9. So one electron from S will fly to complete the orbital here. So it will be 4d10. So 5s1. Type. This 5s1. See how many completely filled shell? Look, complete, huh? Complete, yes. And this complete, okay? Complete. Imagine, like too many screening. خلاص? It prevents the attraction force of the nucleus from this last electron. So it's very easy to fly. Yes. Beside the structure or shape of structure of the lattice of silver. So let's go back about metallic bond. Type. It's bond. Okay. Meaning there is strength. I can say weak, strong. Yeah, because it's a bond. Right. What is the factor influence the strength of that? Mainly, we depend on number of electron, number of valence electron, number or valence of valence shell electrons. So number of electron create the sea of electron. The more number of valence electron, the more strength the bond. Okay, so number of electron, it's direct proportional number of electron, direct proportion with strength of the bond. Done. Okay. Type. If bond is strength, strong type, meaning I'll say here valence shell electron, valence electron. If it is high, meaning high strength of bond, meaning high conductivity of electric, meaning high conductivity, or I'll say thermal conductivity. I'll say increase boiling point because there is a strong metallic bond. So boiling point it will be high, and also melting point will be high, and also hardness hardness of metal will increase. Type. Because someone will ask also, why boiling point increase? Look, boiling point, there is, I'll say there is مثلا bottle here. I'm keeping water here. Why? What is boiling? When pressure of air equal pressure of the surface here, in that moment there is boiling point, and we can separate بقى ايه الفيبر type. And by time you will see here the volume decrease. Where is the rest? It's fly on air. Type. That is boiling. Type. What about metal? One metal here. And as we know, if we focus on one area, we make like this. Like before. Type. And here is a cloud of electron around, creating what? Metallic bond. Type. That one, I need to heating it. Okay, heat it. Let's see. Type. To make boiling, I need to first broke the bond of metallic bond. I need to broke bond, then one of those can evaporate. Then I'll reduce the size like what we said here. Type. So if a strong metallic bond, what will happen? Boiling point will increase. That's logic, yeah. Done? Type. Is there any other factor? Yes. But we will not consider that factor unless valence electron مثلا I make comparison, one metal here and one metal here. This is A, this is B. If here one electron and here one electron and valence shell 1 type. If it is equal, so I look for other factor. What is this other factor, Lowell? Atomic radius. Atomic radius, before we said the valence electron is directly proportional with the strength of the bond. But what about the atomic radius or atomic size? Here, inversely proportional. Like what? If atomic radius is small, خلاص, in that type, it will be a strong metallic bond. Meaning, if atomic radius increase, the strength of metallic bond will be decreased. So it's vice versa. Type. Okay. For example, مثلا sodium 11 type, here potassium 19. This one, outermost is group 1A, of course, type. Outermost have one electron. Type this, one electron. So I can say both same everything character? No. This is a small atomic radius, so that one will have a strong metallic character. Done? Because it's a small atomic radius. Type. I'm talking about the bond, not all the metallic character. Type. مثلا, what will happen if I compare مثلا between sodium, magnesium, both metal, and aluminum? Type. Aluminum 13. This one 12. Type this one 11. Okay? Type. What will say? We know valence, outermost valence shell have one valence electron. Type here have two. Type this one no have three. So valence electron of aluminum more. So aluminum have strong metallic bond than aluminum have strong metallic bond than sodium. Okay, type. I said it will affect the hardness. Yes. Type. If I'm talk about hardness, what? Hardness of sodium compared to magnesium and aluminum. Yeah. Hardness of sodium, I'll say soft. But what about magnesium? Magnesium, we called it bending. Meaning what? Meaning easy to twist. I can make it like this. Okay. But what about aluminum? Aluminum hard, but I can make what's called remodeling. Remodeling. Type. Meaning I can make many shape of it. Easy to reshape. Yeah. Type. What about the melting point? Just to be clear, yeah. Melting point of sodium is 98 degree. Type. What about this? No, sodium more 650, and this one is 660 Celsius. See the effect of valence electron on metallic bond causing this variation. Done? Okay. Right. Let's. Now I know maybe there is confusion will rise up between metallic and ionic bond. No, there is no confusion. Just concentrate. Metallic bond, I'm talking about bond. Type metallic bond and ionic bond. Metallic, I said it's between metal plus metal. Metal cations. طب here no metal plus non-metal. So completely different. And we consider it chemical, but we consider it physical. Type. What else? Here as we saw, the atoms release the electron and create cation. Electron gone away? No, it's floating. I said it's like cloud around the positive ones, like this. But here, no, atoms it completely give it خلاص يعني like give off. Atoms give off its electron, or the other one accept electron. Last. So there is difference between ionic and metallic. Type. What else? Here, electron we said floating over the cations, but here there is connection happen between positive and ion. But here, no, electron is not belong to any atom. It's clear, يعني هسه. طيب. I'll just give you one question just to see is it clear to you or not. طيب. If he told you مثلا, say we have مثلا element X. This element X, I'll say reacted. Reacted with diluted HCl. Diluted with HCl. Reacted with diluted HCl. Type. And it create what? Resulting in salt plus hydrogen gas evolved. يعني X plus HCl اللي هو HCl. He's giving you salt. Salt مثلا we'll say it's Y with H2. طيب. Now he asks you what is the types of bond of X and Y. What type of bond created between X and Y? Type. I know X reacted with HCl dilute, meaning this is just one element. Type. It's react with HCl and make salt and H revolve. H2 evolve. Type. Meaning the salt is XCl because here Cl. Type. XCl. That is called salt. And we know salt is must be with cation plus anion because it's ionic. That's the trick. Type. Now he's asking what bond here and what bond here. This is a question. Type. What bond here? Of course, this is metal, meaning metallic bond. طب here ionic bond because it's salt and salt between cation and ion. As just here in X metallic bond, in XCl is ionic bond. I think now it's too clear what is first type of physical bond, which is metallic bond. Later, inshallah, I'll talk about hydrogen bond. Thank you. See you next.